This is a very old direct current electric motor, or more correctly, a dynamo motor. It can be powered by electricity to act as a motor, or it can be driven by machinery to act as a dynamo to produce electricity. The motor was manufactured in about 1888 by the German AEG company under patents to Edison, taken out in 1883 for the manufacture of light bulbs and other inventions by him. It's one of the oldest, if not the oldest, surviving industrial electric motor in the world and carries serial number 44. Designed to work from 110 volt direct current, it has a power output of about 2 horsepower, weigh about 60 kilograms and stand 370 millimeters tall. The following will show that the motor will run on a much lower voltage than the 110 volts it was designed for. It will also demonstrate the general characteristics of a direct current electric motor. In addition, you will see how efficient an electric motor made in 1888 really is. First, we energize the field coils with 30 volts, then apply 10 volts to the rotor. Notice the armature current rises to 3 amperes, the rotor starts spinning, current then drops to about 800 milliamps. Total power consumption, including the field current, is about 10 watts, less than the light bulb in your fridge. Not bad for a 2 horsepower motor. While running, we apply a bit of braking force on the pulley. Notice how the armature current goes up. We now reduce the armature voltage to 5 volts. Notice the motor still runs. Next, we reverse the connections to the armature. Notice the motor runs in the opposite direction. We now increase the armature voltage to 20 volts. Notice the motor runs faster. Also notice the current goes up while accelerating, then slowly drops back to about 800 milliamps. This is caused by what's called back EMF, where the armature works as a sort of dynamo, balancing the magnetic forces generated in the armature with the magnetic forces produced by the field electromagnet. We leave the armature voltage at 20 volts and reduce the field voltage to 20 volts. Notice how the motor speeds up even more, all to do with back EMF. We bring the field voltage back up to 30 volts and apply 30 volts to the armature. Let the motor accelerate to full speed, then turn the armature power off. Notice the motor runs really fast in 30 volts, and when the armature power is turned off, the voltage only drops off slowly. This is because the motor now works as dynamo while slowing down. Now we spin the armature by hand. Notice it generates a voltage by acting as a dynamo. All pretty amazing stuff for an antique dating back to 1888.